little bit about me. I wrote the first lines of code on the Apache Druid project many years ago. And so I'm a technical person kind of at heart. And this talk is me talking about the things that I've kind of, the conclusions I've come to as I've experienced data working with Druid. I did a stint working with a bunch of data in ad tech and analytics and product analytics and other stuff at Yahoo. I worked at Splunk for a while, seen a lot of data, a lot of things going on, a lot of what people are kind of trying to do with it. And kind of central to this, I want to start with something that probably everyone in the room knows already. And you know, you're all taught in school about this OLTP and OLAP thing. And fundamentally, kind of what you learn is OLTP is for building applications. You want to build an application, you do OLTP. OLAP, that's for doing the analytics. You do the analytics, you get the data between them, and you go. And so we're kind of all taught this, this thought process of, are you building an application? Yes, great, use OLTP. Are you doing analytics? Yes, great. Okay, go do your OLAP system. But what I've noticed is that this kind of dichotomy, this decision tree, is becoming less and less useful. And it's becoming less and less useful for people kind of as they're dealing with data, as they're trying to figure out what's going on. And what I'm going to introduce is a different dichotomy that you can guess from the title of the talk. But I'm going to introduce a different dichotomy that still kind of borrows this and talk about why I think it's an interesting thing. But before that, let's talk about kind of real-world examples. And I do work for this company called Imply. We do stuff with Apache Druid, so there are examples from our customers and people who use our product and all that stuff. And this is one of them. Netflix. Probably everyone knows Netflix. They deliver a streaming experience, lots of members, coverage over lots of countries. We've got all sorts of data. This is one of them. Another one is Ibotta. Ibotta helps consumers earn millions of money in cash back. They've dealt with over 200 million consumers. If you go download their app and install it, they will send you deals, and you can go and buy the things that they send you deals on and get money back for buying things. It's a kind of cool thing. They've given over $74 million worth of money back to people. Reddit, another company, they provide information through communities. They've got over 100,000 communities. Probably everyone in the audience knows of Reddit already, and so don't need to tell you about it. But lots of users and lots of things that are going on. But these are kind of all companies, and what you'll notice from all of them is that they probably have lots of data, but they've got different kinds of data. And so if we think about the types of data, and this is kind of key to understanding the dichotomy and why I think it's kind of not quite as useful as it once was, is when you think about the types of data that go into the different systems, you'll see a pattern emerge. And so take Netflix. What are you going to have in the OLTP system in Netflix? You've got all the videos that people are putting in. You've got the users. You've got all of that sort of stuff. But when they're doing the analytics, they're looking at video views. They're looking at accesses to their website. They're looking at things like that. Ibotta has the cache deals, the deals that are put in, they're stored. You deal with them, people change them, they update, whatever. But then when they're doing the analytics, they're looking at the redemption of it. They're looking at which of these deals were used, what users came and used the thing, talked with it, worked with it, what did they buy, that sort of stuff. You look at Reddit. Reddit in their OLTP systems would have the community information. There's the forum posts. There's who the admins are. There's the user management, all of that sort of stuff. And then the OLAP system, the stuff you're doing analytics on, would be the interactions. Who visited which community? How often did they visit it? What did they do with a post? Did they +1 it or all of that stuff? And so it's the interactions really that are you would use for the analytics. And when you think about this dichotomy of OLTP and OLAP, not from the infrastructure layer, which is fundamentally what OLTP and OLAP is. It's from an infrastructure layer, are we doing transactions or are we doing analytics? Don't think of it from the infrastructure, but when you think of it as from the data modeling side of things, you get two different things. You get entities and events. And that's actually the thing that you're dealing with when you're separating between these worlds. You're either dealing with entities, you're dealing with nouns, users, videos, the deals, the communities. You're dealing with things that exist in the world versus events, which are basically verbs. They're the views, they're the redemption of the thing, they're the interaction, they're what is actually happening and what's going on. I'm gonna dig in a little bit more into what these are. So talking about this more, like what is an entity? It's basically just an object that represents something in the real world. What are the requirements of working with entities? They're constantly changing. You're needing to change, and the thing that people care about is the most up-to-date state. And so one of the requirements of dealing with entities is really ACID-compliant transactions. Now, think about it, and I'll take an example of this conference room, right? We've got, I don't know, some number of people in here. Let's call it 40 people in here. Every time that door opens and someone comes in, that number goes up. When the door opens and someone goes out, that number goes down. The state of this room at any one point in time is what it is. Each time someone goes in and out of the room, you would model that as a transaction applying to the state of this conference room. And it's a similar thing. We can take another example of like a user. You might have a new user created here with some data in a database that looks like this. We've got Sally Sue. And then she updated her address. She now lives on this avenue at that apartment. And you change the date of when it was updated. And then you change the address again. She moved again, you update the address. And also time has elapsed, and so you notice her age has changed too. But the thing about this user is like, you don't really care about the old address. Like, who cares where she lived before? You care about the address right now. You care about the age right now. You care about her gender right now. It doesn't really matter what the old state was. You just care about what the current state is. We can talk about this in terms of e-commerce as well. You have an e-commerce order, and this is just an example order I made up where someone came and they ordered a thing. They want it shipped to 123 Street, the payment via PayPal. They've got the date that it was that they did the order and then the updated date. And maybe the payment was rejected. I don't know, payment processor was like, yeah, this PayPal didn't like them. They're like, nope, we're not doing it. So great, they came back, they put in their credit card, they placed the order again. Now the payment got received, so wonderful. What happens after that? You go to fulfillment. Goes off to the warehouse. The warehouse is like, great, we can now fulfill this, we can send it, we can update. The product ends up fulfilled. It's now been shipped. So the product goes off and it gets shipped. 3 days later, it ends up actually delivered. Now the person comes and they're like, you know, I ordered these 3 things, but one of them I don't want, so I'm going to return it. So now the order gets updated with this partial return because it returned some of this stuff. Notice that the price changed down as well because it was returned. There's a whole lot of change that's happened here, but think about this end state. In this case, you just know that there was this partial return. You know that there's a partial return, you know there's the price at the end, but like what was returned? What was ordered and returned? You don't know, because what this is modeling is that order. Now you could choose to be like, oh, I'm gonna build an array of the things that were ordered and the things that were returned, and I'm gonna model out all the things and all the different things that could have happened. And sometimes people go down that route, but fundamentally this idea is that you have this entity, this notion of the order that is changing over time. And you're updating that state because that's what you're really interested in. Now, there's a lot of infrastructure to work with entities, and there's been a plethora of it. There were the database wars back in the day, and then the relational databases kind of came out and took over, and Oracle took over the world with MySQL and Postgres and all of that. And then, you know, the whole NoSQL movement happened, and we had all the document stores come out where you're fundamentally focusing on a document and having more robust kind of structure inside of it. You've got your key value stores where you're looking at your key value. You've got your graph databases. Fundamentally, all of these things have some notion of what it means to update in a transactional format, what atomicity of update they support, what data is being updated, and you're generally looking at the most recent value at any one point in time, and you're looking at entities. And so when you're working with these systems, you're primarily modeling entities most of the time. Of course, you can put events into them as well, and that does happen, but primarily, like, especially when you're looking at them in the OLTP world, you're usually modeling these entities and relying on that mutation in order to make your product work. So now, events. What is an event? An event is an action that has occurred in the real world, and there's some requirements around events. There's a scale requirement, where there's a lot more scale, there's a lot more events. Go back to the thing that I was clicking through a second ago. There were so many more events that I clicked through in order to get to the entity, where each entity kind of was a thing. There's an auditability. You want to see all the actions. Think about that e-commerce thing, and we'll walk through it a bit. And then there's this notion of aggregation. How do you combine the events together for the big picture? And so let's dive into an example of this as well. If we have an example of an event, and let's talk about a button tap on a mobile app. We have our mobile app. Someone comes, they tap on it, they hit the start button. It responded in 10 milliseconds, great. They then hit the cancel button, and the response time here was 5,840 milliseconds, okay? Maybe what happened? Notice that now they come back and they hit start again, but now they're on an iPhone with a different app. It's the same user, though. So it's a different session, same user, but they're on the iPhone. We then play this out. They actually managed to sign up. They hit their play button in order to play something. Some other user comes along. They go in Android, and it's actually a different version, and they manage to hit start and sign up and do things. And so this might be a series of events that happens for, say, a mobile app that's having some issue with this Android version, and users aren't signing up, so they update the version, and now the Android version, they can sign up, and yay, everything's wonderful. But this notion of the event, this is kind of the audit log. You can see everything that happened. There's multiple different users here that we're talking about, and each of these things, there's an example, or not an example, there's a verb, there's an action that is taken of what is actually happening in the real world. Go back to our e-commerce example, and we're just going to play out basically the same example. We have the order placed, we had that payment rejected, we then had them come back with their credit card, and they came back, they updated the payment type to credit card. It now ended up approved. Fulfillment, what ended up completed. It was then picked up for delivery, and now they've got this tracking ID. It then ended up delivered, and now there's the partial return, and we see that price kind of change here. And here you can see all of the different actions and activities that has happened for this order over a period of time and everything that happened. And one thing to kind of note here, especially with events, is that as we were dealing with the entity kind of view of this, we always had all of the fields available. They're always there. But with this event view, the payment type changed to credit card only when payment changed, not necessarily when it was approved, fulfillment completed, anything like that. We get a tracking ID after it was picked up for delivery. Up until that point, there was no tracking ID. There was nothing associated with it. And new values appear, or values can adjust over time as each event comes. And so each event kind of, it is an action in the real world, but that action has some impact to some other state. It can add more state. It can adjust things. It can do various kind of other things to the entity in the real world. And so this is that kind of verb versus noun setup. And then we have various infrastructure that has fundamentally been built up to work with events as well. And so your traditional data warehouses is your traditional definition of OLAP, right? And if you think about the data that has traditionally gone into the data warehouse, it's all events. It's all an event-oriented view of the world. Even if you're ETLing in your user table, you're basically ETLing in a snapshot of the user table. You're ETLing in a snapshot of your entity tables. And then you have your fact tables that you're joining it up with in order to do your processing. And so the data warehousing and the OLAP world has actually fundamentally existed because of this, existed by having data that you're transitioning from entities into events and combining with other events. You then have the stream processors, and given this is a streaming conference, in order to adopt stream processing, in order to really adjust your systems to decompose the data, decompose your systems to have a stream in the beginning, or in the middle even, you have to convert your interactions into events. You have to figure out some way to make it event-driven, because events are what end up in the stream. You think of, like that's why CDC is so big these days, is because CDC basically gives you those event deltas of what's changed on your OLTP system. Using stream processors is all about first, or using the stream is all about first converting to an event-driven world, and then the stream processors help you work with that world, combine it, pull things together, and look at stuff. And then we have this other box that I'm calling an event DB here, of various different infrastructure that's kind of been built up under this notion of, oh, we have events, we want to be able to deliver an experience that's application-oriented, that's end-user-oriented, that's kind of built up for low latency and can meet the requirements of an application. And this kind of chunk of infrastructure is also built for taking events and being able to deal with them quickly and focus on building and delivering applications. So kind of summarizing here, when we're talking about events versus entities, events, there's kind of two key things about events, and actually I should have highlighted this when I was there, is one, they're time-stamped. If you think about when someone is coming in and out of this room, going back to the example of this conference room, when someone enters this conference room, they entered at a specific point in time. And that never changes. It's immutable. That person entered. That person can leave. It doesn't change the fact that the person entered at that point in time. It changes the state of the conference room. It doesn't change that they entered, and after they exit, nothing will ever change the fact that they exited. So it's immutable and it's time-stamped. It happened at a point in time, because it's basically a verb. It's an action in our real world, and actions always happen in time. Entities, on the other hand, the thing you care about is what is the most up-to-date state? What is the value right now? What am I looking at right now? You don't care so much about that history, and so what you care about is the mutation. You care about the evolution. You care about where it is at that point in time. And so the thing that's most important to the entity is that it's up to date and that you're dealing with that mutation and evolution of the entity over time. So, but here, and I've covered this a bit, there's actually a very direct relationship between entities and events. And it's specifically that events always represent changes to entities. Events are always focused on changes to entities. And so taking the conference room example here, we could have these events where the entity, our conference room, has 3 people in it. 3 people are in the room. 1 person enters, we now have 4 people in the room. 3 people leave, we now have 1 person in the room. The lights turn off. Great. We don't know how many people are in the room anymore because we can't see anything. 5 people enter the room. We still can't see anything. The lights are off. The lights turn on. Whoa, we have 6 people in the room. Each of these events, each of these actions impacted the entity that is the room. And you could have this audit log of the people entering and exiting, or you could introspect the room at any one point in time and see a room with 4 people, see a room with 6 people, see a room with 1 person. The other thing that I find particularly interesting about events is I've been talking about an event as impacting one entity. Events are actually combinations. Events impact multiple different entities. And so like that person that entered the room, they changed. They were moving at a certain velocity, or a certain velocity as they entered the room. When they sat down, they sat down. So that person is another entity in our world that was part of the event of entering the room. The door had to be open in order for that person to be able to come in. And so that door is another entity that's involved in it. Coming into the room, of course, is something that's involved in it. There's lots of different entities that end up involved in any one event. And taking this back to the other things, like if you're talking about mobile analytics, there's the device, there's the user, there's what application they were using, there's who their internet provider was. There's all sorts of different entities in the world that are all come together when you're looking at an event. And when you want to see that event, you want to understand the entities, but you also want to understand kind of how all of those entities came together and worked together to see things. But now in the meantime, getting into the infrastructure, the database itself has been getting decomposed. And this is one of the things that the stream has really introduced to the world or caused to happen, is it's turned into a service decomposition of the database, where the databases, if you go to Databases 101, you'll learn that when you get a command, new data coming in, it goes to a write-ahead log. You then take from that write-ahead log and put it in storage, and then you have your query processing part that runs against what's in storage and returns your results. Now, this write-ahead log is fundamentally the stream. Like, you can think of the stream and Kafka and all of that as the service decomposition of the database as becoming the write-ahead log. Your storage, the object stores and the evolution of that into lake storage and all of that has basically become the service that represents the storage of the traditional database. And now you're seeing a lot of, there's a lot of kind of evolution and iteration on the query engine side of things. What is the right query engine for this decomposed world? Is there one right query engine, or are there multiple? What needs to happen, and all of that? And maybe I see lots of iteration because that's the world that I live in. There's probably tons of iteration in the other parts of the world as well. But this is kind of what's happening to the database as a whole as the stream has been introduced and we've moved on to more kind of cloudy, internet-y type things. But central to this is that events are the lingua franca of this decomposition. And actually, even here, the write-ahead log in the traditional database, what was stored in that write-ahead log was an event. It was a delta. It was some action that you can take against storage in order to make the change happen. And so this event notion has actually existed underneath all of this for a very long time. And the events are kind of central to this decomposition. And you might think that, okay, this is the picture. Then you have your events, they go to the stream, you get the stream into your storage, and then from the storage you query. But one thing that comes out with this decomposition, specifically with the stream, is that if this is the extent of the picture, then you are limited on your query engine by the latency of how quickly you can get stuff into your lake storage and make it available for read. And with the way object storage works and all of that, like, that can be a latent process. It can be seconds. That can take time, and that might not meet an SLA. And so what you end up needing is you need this query engine to also be able to consume from the stream. You need it to also be able to process data off of the stream so that it can have the most recent data as well as what's ever in storage and combine them together in order to produce results. And now we're going to get into a little bit more kind of future-facing stuff. But I think the way that these query engines are going to go as well is that they're going to move towards this notion of kind of more explicitly separating this idea between entities and events. And knowing that, okay, I've got events coming in. Am I modeling an entity, or am I dealing with a slab of events? Am I dealing with an audit table of events? And how am I processing? And this query engine is kind of going, it's going to be evolving towards what it means to effectively consume events and then give you the ability to see both entities and events depending on what is right for whatever your use case is. So now we switch into the talking about ourselves for a little bit. Druid, we're built for the event-driven ecosystem. If you don't know about Druid, we're a kind of OLAP system that deals with events. We've consumed stuff from Kafka for a very long time. We have the async queries that we can run from your lake. You can do arbitrary SQL, pull it in from the lake, but we also have native streaming integration. We run as a streaming consumer directly off Kafka, can pull in data, do exactly once ingestion, scale out, make that queryable. Basically, as soon as the consumer sees the data from Kafka, it will be reflected in query results. And then we've been built to, as I mentioned a little bit earlier, we've been built to support application requirements, higher concurrency, sub-second query responses, kind of aligning with what people expect when they're interacting with an application. We've all kind of been spoiled by the Googles of the world and the Amazons of the world. When you go to the website, it just loads. It loads fast, and you don't think about it. And if you ever see a loading screen, you get really annoyed. And because of that, we've all been led to believe that applications should be interactive. You should be able to see stuff quickly. And so that's now a requirement, really, in delivering any sort of application to end users, is really having an interactive experience. So now we come back full circle to some companies that are using us for this stuff. And so Netflix uses us primarily in kind of an observability use case. They get a lot of their logs from devices. And so these are logs, it's events, it's what's happening on devices, it's what's happening with viewing. They pump that data in, they convert it into telemetry via stream processing, pump it in, put it in Druid, get some visibility of things. Ibotta uses us for security and fraud, going back, looking at the cash back deals that they've talked about. Having all of the data of cashback redemptions, what's happened over time, being able to go back, explore, understand why something happened, look back and, I don't know, find crime syndicates, people who are trying to steal money from them without actually buying things and just getting cash back. They use us to funnel all of that redemption data in and then be able to look at it kind of historically and longitudinally to understand everything that happened at an aggregate level, as well as down in. And Reddit uses us for some of their real-time advertising, understanding the ad use cases, how the bids are working in marketplace. We're actually used pretty widely in the ad tech space for understanding how marketplaces are performing, advertising analytics, users and user demographics, and all of that sort of stuff. And really, these are all instantiations of this kind of pattern of the decomposition of the database. There's this generation of data that's happening out on the devices, on the edge, on whatever. It's funneling in through a stream. And it's fundamentally it's events. It's events funneling in through a stream, whether it be Kinesis or Kafka or whatever, ends up flowing into Druid and then being exposed directly to an end user via some aggregation, some query time processing directly on those events. That kind of does it for my thing. I think I spewed something that I find interesting. It's something I think, anyway, it's something there at everyone. We have time for questions. If there's any questions, I'd love to chat. Field it.